Hi all, welcome to my channel, and today we'll be solving this very famous question, coin change. And in this problem you're given an integer of coins representing the coins with different denomination and an integer amount representing the total amount of money you have to make. So you have to use the fewest number of coins that is possible to make up that amount, and if this amount is not you cannot make that amount using any combination of money, then you have to return -1. And as you see the first example, you have these coins, so you can use either 11 times 1 or to make this amount 11, but the minimum possible combination is using the denomination with value 5 2 times and 1 as 1 time, so the output should be 3. So in example 2 we have this amount 3 and the coin is 2, so you cannot never make this amount using this coin, right? Because you cannot break it into chunk and all, we are assuming that. And so you have to return -1 in that case. And in case when amount is 0, then you really don't need any coin to make it up, so the output should be 0. Looking at the constraints, we have this coin's length, so you have the number of denomination that will range from 1 to 12, and the value of this denomination can lie between 1 to this integer maximum value, and the amount can lie between 0 to 10 to the power 4. So let's approach this using dynamic programming, using iteration. So we will make one 2D array, let's name it TP, and so in this TP, in columns we will use the amount that we have to make. So in one example, let's say we are given this amount 7 and some denomination, that is coins array having values 2 3, and yeah, so to start with, let's put that in row, the values that we have to achieve, like 0 1 2 3 4 5 6 and 7, and in this column value we have this denomination. So let's assume we have this 0 denomination as well to verify the base cases and all, and in that we are deducing the big solution from the base cases in dynamic programming, so that's why we are considering the 0 also. And then we are given these denominations like 2 and 3, so we are making this 2D array. Yeah, so to make amount 0 using any denomination, you don't really need any denomination. So the first column will have this value 0, right? And for these values you cannot make any of these value using value denomination 0, so we can write it as some infinite number, because infinite into, so you can never make this number using any number of points, so we are assuming we are using infinite value here, right? So these are representing the value in this DP array is representing the minimum number of points needed to make up that amount. Yeah, so coming to 1, so you cannot make that 1 from 2. Why? Because this value is very less than this value. You cannot make it into chunk and put it to make that value. So that's why whenever we have the case, like if we assume these are the j values, right? So these columns are j values, cursors moving around, and these are I values, right? So we have added 1, so whenever we have to access 2, then we will say I coins of, so in the coins array it is at index 0 and 1, but in this DP array it is at index 1 and 2, so that should be coins of I -1 to access the ith value, right? So now and in our first case, whenever this j value is less than this coin value, so we can never make this so if in case this coins of I -1, so if this is the case, then what we will do, we will check the previous row if it has made any value out of it. So we can directly put the value that is present in the last row, that is dp of, in this case, so we will write it under if condition, and then we have to write dp of I minus 1 and j, right? So this is the value that we will put in current dp, so that is directly infinity here. And now for moving forward, we have to take this value, we have to compare between this value, or using current denomination 1 plus the amount that is coming after reducing the current denomination from the current value. So what I am saying is you have to take minimum between this value first, like dp of I minus 1, because any lower denominations can also make up the amount, and then the value that the minimum coin can be lesser, so we always need to consider that as well. So that is dp I minus 1 and j, or 1 plus, so we are using current denomination in this row, and dp of j minus coins of I minus 1. Y minus 1 means current, dp of I and coins of I minus 1, so this is the current denomination value. So this is 2 here, in this case this is 2, j is 2, so dp of 2 and sorry, I missed this I thing, so current row, yeah, so dp of I, dp of this I is 1, right, and this is 2 minus 2, so this is dp of 1 comma and 0, so this is basically this value 0, and we are using current denomination, so 1 plus this, yeah, and this value is already there, that is infinity. So to pick minimum between these two, you will get answer 2, sorry 1, not 2, so this is 0, right, so 1 plus 0, so the value will come as 1 here. Now moving forward, if we see this value 3, right, so we have to compare this value, that is this thing, and in this case if we see that is infinity, and 1 plus dp of, in the current row itself, 1 j minus, j is 3, minus coins of I minus, so the current denomination, that is 2, so dp of 1 comma 1 is infinity, so for this case it will come as infinity, so you cannot make 3 from denomination 2, right? So similarly we will move forward, so let's jump into the code and let's code it up. Yeah, so the base case we can always write, and if this amount is 0, then we can simply return this amount, right, that is 0 itself, or we can write 0, no problem. Yeah. And next what we need to make is this dp array, right, new, and okay, so the length and row, so this number of rows and the number of, so this is basically the amount plus 1 length, amount plus 1 length, because we are adding this 0, so this is index 0 to 7, so we have to take the length 8, then we will have this index 0 to 7, right, and similarly here we will always take one length greater than the coins length. So new int array coins length plus 1, then this is amount plus 1, right, and now iterating over, first thing is this coins length, and then iterating over the dp array we have this amount thing, right? So yeah, so this will cover the entire iteration. So if first case, if I is equal to 0, so this is it means this thing, right? In this case we can always write dp of I and j is the maximum possible amount. So what is the maximum possible amount? And the constraint is 10 to the power 4, so we can take 10 to the power 5 or something, right? We are not taking integer dot max val because when you add 1 to integer max val, it will change the sign, because the value will overflow the capacity of integer. So that's why we are taking simply 10 to the power some more than 4 zeros, some okay, more than 4 powers, so we can take anything like that. Then else if j is, whenever this j is 0, so you are staying in for the first column, then you have to put dp of I j as 0, right? And in case the coming up to the third case that we discussed, whenever this j is lesser than coins of I minus 1, so coin of I minus 1 is the current denomination, so whenever this amount is lesser than this denomination, so we have to take the previous amount, right? So in this case it will be simply dp of I and j is equal to dp of I minus 1 and j, the previous row value, the low. And then we have the last condition where we have to pick the minimum between two cases, right? So dp of I and j is it's math min between dp of last row I minus 1 and j, or 1 plus, so subtracting the value from the current row, j minus coins of I minus 1. Yeah, so this is the denomination value, right? So and whenever we are unable to meet that amount, then in our solution it will come as this value, right? So we have to return -1 in that case. If dp of, and also we have to note that this thing, so the last row and the last column will have the minimum number of denomination that is needed to make up this amount. Okay, so that is basically coins length and amount. So this is the value, and if this is this value, this largest value, then in that case we have to return -1, or else the value itself, right? Yeah, so I have written some small test here, so let's run and see this if it is working fine. So in this case we have 2 and 3, and we have to make this amount 7, so we need two denominations and denomination, and 1 this 3 denomination, so the value is 3. So this seems to be working fine. Let's run it on LeetCode platform. Okay, so I pasted it. Let's run the example test case. Yeah, it seems to be working fine. Let's submit it. Okay, so this is an accepted solution. So this is the best way I can think of. So let me know in comment section if you have any doubt. I will try to answer all those questions. Thank you very much for watching.